Here's a question on projectile motion from pre-calculus. A baseball is hit when 3 feet above the ground and leaves the bat with the initial velocity of 150 feet per second at an angle of elevation of 20 degrees, parametric equation to the horizontal and height. So it's going to be x, parametric equations, always x and a y. I'm going to get x of t, because it's in relation to time, equals, it's going to be the initial velocity plus, and then it's going to be, not plus, times 150 times cosine of 20 degrees. I better put the degrees there, times t. I was just trying to see how they wrote the answer on the answer sheet. They just left it like that. You could also do cosine of 20 degrees and multiply it by 150 and then write that number in front of t. Y of t, remember, it equals the initial height, which in this one is 3 feet, plus 150 sine of 20 degrees times t, and then you have to account for gravity, minus 16t squared. So those are the parametric equations. There's a fence that is 400 feet from home plate. How long does it take? Well, I'm just going to make the x distance 400. 400 equals 150, because that's x distance, cosine 20 degrees times t. So t would equal 400 divided by 150 cosine 20 degrees. And let me see what that equals. I'll go to my old Desmos. I think I already have that. Yeah, 2.838, about 2.838 seconds. 2.838 seconds. Okay, this is the exact answer. This is approximate. I think in the answer key for the next one, they just use the approximate. The fence is 20 feet tall. Does the ball clear the fence, earning the batter a home run? That's going to be the y equation. I'm going to do the y parametric equation of 2.838. So I'm just going to plug 2.838 into this. Equals 3 plus 150 times sine of 20 degrees times 2.838 minus 16 times 2.838 squared. And I've already done this on Desmos. Although I used x because that's all I can do on Desmos, that's the y parametric equation. So I just f of x or y of t, and I put in 2.838 for t. It's approximately 19.73 feet. Well, this says the fence is 20 feet. So here's the fence. Here's the batter. Boop, 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 boop. It hits almost to the top, but it doesn't clear the fence. So no home run, no home run. Now, there could be a scenario. What if the fielder fell down? Let's say this was in right fielder. The right fielder fell down, and the center field comes running over, and he falls down. Both of them is twisted their ankle. They can't stand up. The left fielder has to run and get the ball that has bounced off the fence or the wall. Meanwhile, the runner sees this, and he runs around the base. He gets an inside the park home run. So it could earn a home run, but not flying. It's not going to clear the fence. That's what the question is really asking. Does it clear the fence? So there's that question. Parametric equations or projectile motion. The ball is a projectile under these scenarios.